Welcome to this video on the multiplexer, or MUX, a key component in digital electronics. A multiplexer is fundamentally a data selector circuit. The basic idea is many inputs to one output. A multiplexer is a combinational circuit operating on current inputs. It's often called a universal switch because it accepts data from multiple lines and routes it to a single output. It uses select lines to choose exactly which input gets forwarded, earning it the alias, Data Selector. The basic concept of a MUX is the many-to-one funnel. Imagine 4 highway lanes merging into one. The select lines act as a traffic officer, deciding which lane passes through at any given second. In a general multiplexer block diagram, a typical MUX handles 2 N data inputs using N select lines. The data inputs are labeled D0 to DM, and the single output is Y. The select lines determine the input-to-output path. The multiplexer has 3 main components. Data inputs are the raw lines of binary data, usually 2, 4, 8, or 16 lines. Select lines are the control signals. A specific binary code on these lines selects one data input. The output line is the single exit route that copies the data of the chosen input line. The 2-to-1 multiplexer is the simplest form. It has 2 inputs, D0 and D1. Since 2 to the power of 1 equals 2 inputs, it requires only one select line, S, to choose between them. It produces one single output, Y. This is the block diagram for the 2-to-1 MUX. We see the 2 data inputs, D0 and D1, the single select line, S, and the single output, Y. The 2-to-1 MUX truth table shows how the select line determines the output. If S is 0, D0 is connected to the output. If S is 1, D1 is connected to the output. The Boolean equation for the 2-to-1 MUX output is Y equals SY asterisk D0 plus S asterisk D1. If S is 0, the D0 term is active. If S is 1, the D1 term becomes active, resulting in the correct data routing. Moving to the 4-to-1 multiplexer, it has 4 distinct data inputs, D0, D1, D2, and D3. Because 2 to the power of 2 equals 4, it requires exactly 2 select lines, S1 and S0, to generate 4 unique combinations. As always, it has one output, Y, which routes the chosen data line. Here is the block diagram for the 4-to-1 MUX, showing the 4 inputs D0 through D3, the 2 select lines S1 and S0, and the single output Y. The 4-to-1 MUX truth table demonstrates the selection process. Different combinations of S1 and S0 determine which of the 4 inputs, D0 through D3, is routed to the output Y. Multiplexers have several key applications. They are used for data routing, sending data from multiple sources to a single destination. In communication systems, they transmit multiple signals over a single cable. Finally, for CPU data selection, the CPU uses MUX to select data from different registers for the ALU. The advantages of using MUX are significant. It reduces wiring, which lowers manufacturing costs. It provides efficient data selection with incredibly fast switching. It also simplifies logic design, allowing implementation of complex Boolean functions without separate logic gates. In summary, the multiplexer is a data selector, acting like a funnel. Select lines are the steering wheel, determining which input is forwarded. The most common types, the 2-to-1 and 4-to-1 multiplexers, form core building blocks for data routing networks. Thank you for watching this video on multiplexers. We hope you keep learning and keep growing.